All right, let's take a look at some of these problems where you have to take a derivative of a function being raised to the power of a function. Okay, so for your base, you have a function, and your power, you also have a function, right? So when you're dealing with these kind of problems, and if you want to take the derivative, I've seen some students try to apply the power rule here, and if they apply the power rule, it would be g of x times f of x to the power of g of x minus 1. And although the power rule has technically been applied correctly, you simply just can't use the power rule to take the derivative of a problem where you have a function being raised to the power of a function. The power rule only works when your exponent is a real number, not a function. So please do not apply the power rule for these kind of problems. Instead, what you want to do is you want to use a combination of logarithmic properties and then take the derivative of both sides of the equation here. So how do you apply your logarithmic properties? Well, you have to start by lnning both sides. So ln y equals to ln of everything on the right-hand side, which is x to the power of ln x. Right, so once you ln both sides, which is mathematically correct, you can start using the logarithmic properties. And the main property you want to use is that the power here, which is ln x, you want to be able to move that to the front. And so sometimes I'll say you soccer kick that to the front. So ln y would equal to ln x times another ln of x. Okay, so you have correctly applied the logarithmic properties, and now you can differentiate both sides. All right, so how do you differentiate ln of y? Well, that's simply going to be 1 over y times y prime equals 2. And then on the right-hand side, you would want to apply the product rule, right? So the derivative of ln x is going to be 1 over x. And then you multiply that by the second function, which is ln x, plus the first function times by the derivative of the second function. All right, so that right there is your that right there is your derivative. And then what you want to do next is on the right hand side, you want to do your best to clean this up. So if you have ln x times 1 over x, that's simply going to be ln x divided by x plus, and then you have a ln x times 1 over x, which is ln x over x again, basically the same thing. And then you have a y prime over here. And then what we're going to do next is we notice that there's a 1 over y, right? So how do you get rid of that 1 over y? Well, you want to move it to the right-hand side by multiplying everything on the right-hand side by that y. There you go. So now you have y prime equals to ln x plus ln x times y. And then finally, what you want to do is, I guess since you have the same denominators here, a common denominator here, you can add the fractions. All right, so the denominator stays the same when you're adding fractions, and then if I add the numerators, ln x plus ln x is going to be 2 ln x. Close the bracket. And then ask yourself, what is y equal to? Well, y is essentially the original question, so y equals to x to the power of ln x. So what you want to do there is you want to just multiply this by x to the power of ln x. Okay, so this y is just the original function, which is x to the power of ln x. And that right there is your final answer. And let's move on to the next question. I feel like once you have done enough of these kind of problems, the steps are kind of repetitive, and once you get more familiar with it, it's actually not too hard, even though you might have to write multiple steps. All right, so part one, we have a function raised to the power of a function. So in order to get this function down, you need to ln both sides. So once you ln both sides, you can start using the logarithmic properties. And then if I ln this side, I have bracket x squared plus 1 to the power of cos x. Okay, and then as I mentioned earlier, once you use the logarithmic properties by lnning both sides, you can take that cos x and you can soccer kick that to the front. So that's one of the main logarithmic properties that you want to be able to use. So now I have ln y equals to, I'll put this in brackets, cos x, and then you multiply that by ln a bracket x squared plus 1. Alright, so now that you've used the logarithmic properties correctly, you can now move on to your derivative rules. So let's go ahead and find the derivative of both sides. So the derivative of ln y is 1 over y times y prime equals 2. And then on the right hand side, we can apply the product rule. So the derivative of cos x is going to be negative sine x times it by ln of bracket x squared plus 1. And then the product rule states that you need to add the first term, which is cos x, and then you multiply it by the derivative of that second term, which is 1 over x squared plus 1. And then applying the chain rule, the derivative of x squared plus 1 is going to be 2x. All right, so there it is. There's your derivative. And what you want to do now is you want to do your best to clean it up. Okay, so this will be bracket negative sine x times ln of bracket x squared plus 1. And then what do I have over here is, I guess I have a cos x and a 2x. And I guess if we multiply that out, we'll get a positive, a 2x bracket cos x, all divided by x squared plus 1. And then I guess on the left hand side I have a 1 over y times y prime. Okay, so that looks right so far. And I guess one of the things I can do because I have, one little thing I can do because I'm doing this as a video is that I notice that there's a 1 over y here, right? And if I want to get rid of that, then I can simply multiply this whole thing by that y, right? So I can essentially move this y over there, so times by y, and I can erase that, and now I have this. All right, so this is looking pretty good now. So y prime equals to all that, and once again, ask yourself what is that original y, and that original y is essentially the original function, which is this thing right here. So you have one final substitution step. You want to be able to change that y to the original function, and that original function was x squared plus 1 being raised to the power of cos x. So that right there is your final answer for question number 3. Okay, let's move on to the next one, question number 5 here. So once again, I have a function x, and I guess that's being raised to the power of e to the power of x. Okay, so a function raised to the power of function, so you want to ln both sides. So ln of y equals to ln of x to the power of e to the power of x. All right, so that's step number 1, and maybe I'll just put a bracket right here. Actually, let me just erase all this again. If I ln that side, there's a bracket of an x raised to the power of e to the power of x. Okay, hopefully that's a little bit more clear. And then what we're going to do next is this power right here, e to the power of x, we want to soccer kick that to the front on our next step. So now I have ln y equals to e to the power of x times ln of bracket x. Okay, and then now we can apply the product rule because our next step is to take the derivative. So this e to the x times ln of x, and how do I take the derivative of ln y again? Well, that's going to be 1 over y. So this is coming up a few times already throughout the video. And then if I apply the product rule here, the derivative of e to the x is e to the x times ln of x plus e to the x times 1 over x. Okay, let's go ahead and simplify this as best as we can. So on the right hand side, I have e to the x times ln of x plus e to the x all over x. Okay, so let's go ahead and clean that up, and then I guess I have 1 over y times y prime. All right, perfect. So that's looking pretty good. And in my last example, I was trying to get rid of this 1 over y by multiplying both sides by y. So if I do that, the right hand side is going to be multiplied by that y. So that y would now go there. And then I can erase this 1 over y over there. Okay, so technically this is correct, and the last thing we're going to do here is we're going to substitute the original function here. So once again, what is this y here? That y is the original function, and the original function was x to the power of e to the x. Okay, so if I erase this, I get a bracket x to the power of e to the power of x. Okay, so there you go. There's your final answer for question number 5 there. Okay, let's move on to next question here. So question number 8 here. Okay, so over here I have e to the power negative x times cos x times the cube root of x squared minus x. Okay, so in class you may recall me writing things like this, ln of ab divided by c. And if you want to use your logarithmic properties on a question like this will simply be ln A plus ln B minus ln C. All right, so we're probably going to be using that particular property throughout this problem here, and I can use that property once I ln both sides. So I ln that side, and if I ln this side, then the question is now going to be eligible for these logarithmic properties. Okay, so this A here, if I look at this A, the A is really going to be like your e to the power negative x. This B is really going to be the cos x, and this C is really going to be the denominator right there. Okay, so if I want to apply the logarithmic properties here, I'll try my best to kind of write this carefully. So I would have ln of e to the power of negative x plus ln of cos x, and then subtracting the ln of the cube root of x squared minus x. Okay, so there you go. We quickly apply the logarithmic properties here, and what I'll do next is I'll just continue to simplify this as much as possible. So I'm not taking the derivative just yet. That's very important for students to understand that. I'm not taking the derivative. I'm going to continue using logarithmic properties. So I see a negative x there, so I'm going to soccer kick that to the front. I'll write that as negative x in a bracket, and I'll times that by ln of e plus ln of cos x, and then minus. Now this part over here, I guess I can write this as ln of bracket x squared minus x to the power of 1/3. And then please don't write that step out just yet. This 1/3, we can also soccer kick that to the front, right? So that's going to be really 1/3 times ln of bracket x squared minus x. So if I just kind of have to kind of erase this here, let me erase this now. I'll write this as 1/3 times ln of bracket x squared minus x. Okay, so there you go. That's what I have right there. So I've quickly used all my logarithmic properties here. The last logarithmic property that I'm going to actually apply before I start taking the derivative is that over here I have ln e, right? So ln e is going to be 1. So I can erase that, and really that's going to be a 1, right? So negative x times 1 is going to be negative x. So I'm going to erase all that and just write that as just negative x with all that. Okay, so now that I've simplified as much as possible, now I can find the derivative. So taking the derivative of ln y is going to be 1 over y times y prime equals 2. Now the derivative of negative x is going to be negative 1 plus, now the derivative of ln of cos x will be 1 over cos x times the derivative of cos x, which is negative sine x. Okay, and then we have a minus sign here, and then we have the 1/3 times, and then the derivative of ln of x squared minus x will be 1 over x squared minus x times by 2x minus 1. So that is the chain rule right there. Okay, so there's a lot going on here, so let's do our best to kind of clean this up now. So now I have 1 over y times y prime on the left-hand side. This negative 1 will remain, and then I have negative sine x divided by cos x, and if I multiply all that out, essentially I get negative, well, sine x all over the cos x, and sine x over cos x is going to be tan x, so I'm really subtracting tan x here. Right, and then if I go ahead and multiply this 2x by the 1 and this negative 1, I guess what we have there is we have a negative bracket 2x minus 1, and then we're going to divide that by the 3 and then the x squared minus x. All right, so this 3 right here is going to be that 3 right there. Okay, so that's looking pretty decent here, and then one thing that I've been doing throughout this this particular video is how do I get rid of this 1 over y? All right, so if I want to get rid of that 1 over y, you actually have to multiply both sides of the equation by that y. So this y is going to simply be multiplied over here as well, and then I can officially get rid of that 1 over y here. And there you go, that expression is looking pretty decent here. And then once again, what is this y equal to? Well, that's equal to the original function here, and the original function is a little bit ugly. If you recall, it's actually going to be e to the negative x times cos x, all divided by the cube root of x squared minus x. All right, so that's it for that particular question there. It was a little bit longer and a few more steps involved, but hopefully the steps weren't too confusing. Okay, let's move on to some of these other word problems here, or application problems. So find the slope of the tangent line to the curve y equals all of that at x equals to 1. All right, so I need to find the slope of this particular example here. And let's start by, let me start off by maybe perhaps moving over here. And I guess what we need to start by, if we want to find the derivative here when x equals to 1, we should start by lawning both sides. So ln of y equals to ln of everything on the right hand side, which is x plus 1 all squared divided by x cubed times x minus 2. Okay. So what I see right here is this is kind of like your A, this is your B, and this is your C, right? So if I have to write a separate statement over here, it would be ln of A over B ln of A divided by B times C. And if we had to kind of break this down, it would be ln A minus ln of BC. And then if we keep on breaking this down, it would be ln A minus, and then you need a bracket here, and this would be ln of B plus ln C. Okay, so remember this product right here can be written as a sum, so ln B plus ln C, and then we're going to have to distribute that minus sign through. All right, so just by looking at this question, this is what I foresee, and we're probably going to have to apply most of these rules as we're kind of simplifying this problem here. Okay, so let's go ahead and apply the logarithmic properties here. So I have ln y on the left-hand side, and on the right-hand side, let's start breaking this apart now. So this is ln of bracket x squared plus 1 all squared minus ln of x cubed. And then, actually, let me put this in a bracket here. And then I'll have my plus sign x, and then plus ln of bracket x minus 2. Okay, there you go. All right, maybe we'll just kind of erase this now so that I have a little more space up here. Okay, let's go ahead and simplify this as much as we can here. So on the left-hand side, I have a ln and then a y equals 2, and then there's a power of 2 there, so we can start by soccer and kicking that to the front. So that's going to be 2 times ln of bracket x plus 1. And then this minus sign here, let's just distribute the minus sign first. So if I distribute the minus sign, I have a minus and then ln of x cubed, and then minus a ln of x minus 2. Okay. And then one more thing I'm going to do over here, I'm going to soccer kick that 3 to the front here. So if I soccer kick that to the front, this will be a minus sign here, and I'll put the 3 there, and then I'll erase that 3 there. Okay, so there you go. We've simplified as much as we can there using logarithmic properties. And then I guess what we can do now is we can now differentiate both sides of the equation here. So ln y is going to be 1 over y times y prime equals 2 times, and then what's the derivative of ln of x plus 1? Well, that's 1 over x plus 1, and then times by 1, which is just, which wouldn't change anything, minus, and then I have a 3 there, and then the derivative of ln x is 1 over x. Okay, and then I have a minus sign there, and then the derivative of that is going to be 1 over x minus 2. Okay, so that's looking pretty good so far. And then I guess what we can do now is that we can simplify this as much as we can. So 2 times 1 over 1 plus x is going to be 2 over x plus 1 minus 3 over x, and then minus 1 over x minus 2 equals to 1 over y times y prime. I can now get rid of this 1 over y by multiplying both sides by y. So actually, never mind. What I like to do is I can put a bracket around this, and I can multiply by that y, which is that right there. Okay, so let's erase all that and erase that. Okay, so so far so good. And before I haven't actually even solved the problem here because I need to find the value of the slope. I'm just kind of rewriting everything in logarithmic form here. And what was this original y again? That was the original problem here. So let me erase that and now substitute that with the original problem, which was x plus 1 all squared divided by x cubed times x minus 2. Alright, so that's looking pretty good now, and instead of writing y prime now, I guess what I'll write is, the notation might be incorrect here, but what we're really doing is we want to find the derivative when x equals to 1, right? When x equals to 1. So what we're going to do here is all these x's are now going to be replaced with the value of 1. So let's go ahead and see if we can do the numbers in our head here. I have 2 there, and if x equals to 1, I guess that's going to be 1 plus 1, which is going to be 2 on the denominator, minus 3 divided by 1, and then minus 1 over 1 minus 2. And then over here, if I substitute 1's here, here, and there, 1 plus 1 is going to be 2, so I guess we have 2 squared on the numerator divided by 1 cubed is 1, and then 1 minus 2. Okay, so we've got to figure out what this all equals to kind of figure out the last part of this problem here. So 2 divided by 2 is 1 minus 3. Okay, and then I guess this right here would be a negative 1, and then there's a minus and a minus, so that's going to be plus 1. And then we're going to multiply that by, okay, the 2 squared is going to be 4 divided by negative 1. Okay, so that's looking pretty good, I think. Okay, so let's go ahead and finish the math here. So 1 plus 1 is going to be 2, and then 2 minus 3 is going to be negative 1. So this will be negative 1, and then we're going to multiply that by negative 4. And my final answer here is going to be positive 4. So the derivative when x equals to 1 has a value of 4. So the slope is 4 in that particular example. Okay, all right, let's move on to the very last question here. Okay, so I have some information given to me. So f of 2 equals to e, f prime of 2 equals to 3, and I need to find h of x. So this is the function that's given to me. H of x equals to f of x to the power of f of x, and I need to find h prime of 2. Okay, so not a problem. Some fancy notation, but we're going to start over here, and we're going to start by loging both sides here. So ln of what? Ln of h of x equals to ln of bracket f of x to the power of f of x. Okay. And then once we've ln both sides, we can use the logarithmic properties, and the main one here is this function is going to be a soccer kick to the front. So on the left hand side, I can write ln of h of x equals to f of x times ln of f of x. Alright, so now that I've applied the logarithmic property rules, I can differentiate both sides. So the derivative of this is not 1 over y times y prime, but it's 1 over h of x times h prime of x. And then on the right hand side, I can apply the product rule here, so f of x times ln of f of x. Okay, so the derivative of f of x is going to be f prime of x, and then I can multiply that by ln of f of x plus, and then plus the first function, which is f of x, and then times it by the derivative of that, which is 1 over f of x times f prime of x. Okay, so let's see if we can simplify this. What I see here is there's an f of x times 1 over f of x. So those can technically cancel, and I guess you're left with just the f prime of x. So if I erase all this, I have plus f prime of x. Alright, and then I guess what we can do now is I guess we can start substituting the values here, because what we're asked to do in this particular problem is I need to find h prime of 2, right? So for sure, if you want, you can isolate for h prime of x, which is what we've been doing for a lot of the problems here. Actually, instead of writing that, how do I get rid of that part there, right? So I can multiply both sides of the equation by h of x. So the h of x can now move over there. So that move is, we've been using that quite a bit throughout this homework video, guys, so hopefully that's not confusing there. And then now that we have that, what we need to do now is we need to evaluate, the final question is I need to evaluate h prime of 2. Right, so that's the question here, right? Was h prime of 2? And what that means is all these x's are going to be replaced with 2. So this will be f prime of 2 times ln of f of 2 plus f prime of 2 and then times of h of 2. Okay, and then after that, we're just substituting the values that are given to us at the start of the problem here, and then we can kind of finish off this problem here. So we're given that f of 2 is e, and h of 2 is going to be f prime of 2 is going to be 3 there. So let's see if we can apply those particular numbers to this particular problem here. Okay, so sorry, let me see. F prime of 2 is going to be 3. Okay, so if I multiply this, f prime of 2 is going to be 3, right? So this will be 3 times, now what's f of 2 here? F of 2 is going to be e, so this is going to be times ln of e. So f of 2 is going to be e, right? And then plus f prime of 2, well, we know f prime of 2 is going to be 3. It's the same thing as that, right? And then I need to multiply all that by h of 2. Now, remember, what was the original function here again? So the original function was h of x equals to f of x to the power of f of x. And if I want to find h of 2, that's going to be f of 2 to the power of f of 2. Now, what is f of 2 equal to? Well, f of 2 is equal to e, right? So this is really e to the power of e. So that's what h of 2 equals to. So I can multiply the whole thing by e to the power of e. And then we can kind of, then we're pretty much there, right? I would say ln e is 1. So this is now going to be 3 plus 3 times e to the power of e. And 3 plus 3 is going to be 6. So the final answer here is going to be 6 e to the power of e. All right, so that's it for this homework video guide.